NASA spacecraft are turning their attention to an unusual object speeding through our solar system. NASA-funded telescopes have their eyes on the sky all the time, and first spotted this object back in July.
On a quiet night, sky watchers scanning the deep backdrop of Sagittarius noticed something subtle yet unusual drifting among the stars. It began as little more than a faint, wandering point of light, difficult to tell apart from the background, but within hours, automated sky surveys flagged a strange feature. The object was moving, with a velocity outpacing ordinary solar system bodies. Soon, observatories from Mauna Kea to La Palma had their sights on this unexpected arrival, confirming that it was no ordinary visitor. Astronomers designated it 3I/ATLAS for the survey that first detected it, and 3I, marking it as only the third confirmed interstellar object recorded in our solar system's history. Its discovery was a reminder of our solar system's openness, a crossroads for objects traveling across the galactic expanse. Most visiting comets and asteroids are known, long-period travelers from the Kuiper Belt or Oort cloud, icy or rocky fragments that return every so many centuries. But here was a traveler from far beyond, a messenger whose home could be a planetary system that formed long before life in our own solar system began. Immediately, 3I/ATLAS proved to be more than a curious new dot on astronomy maps. Its remarkable speed and its hyperbolic trajectory, one ensuring it would never return, confirmed it as an interstellar object. Its origins lay somewhere in the vast gulf between stars, much farther than any probe or spacecraft has ventured. For astronomers, this was a rare opportunity, a glimpse at the building blocks of other planetary systems, thrown into the darkness by unknown forces. Still, discovery quickly gave way to complexity. Observers raced to predict its path. Would this comet sweep past the Sun and, like its interstellar predecessors, disappear into space? With each new image, astronomers performed careful calculations, but some results were anything but routine. Early measurements fit the model of a typical interstellar interloper until small inconsistencies began to show. Updates to its predicted path revealed minor yet measurable anomalies, subtle accelerations or course deviations that could not be dismissed as simple error or noise. Unlike most visitors, which track faithfully along Newtonian trajectories, 3I/ATLAS seemed to undergo unexpected changes. These variations, though minute at first, persisted. Observatories around the world, including the European Southern Observatory, Pan-STARRS, Japan's Subaru Telescope, and responsive satellite platforms, collaborated to refine its course and behavior. As the mystery deepened, new images revealed a faint, blue-tinged tail. Data from Hubble and ground telescopes showed a tail forming at extremely high speeds, jets of dust and vapor accelerating away faster than what's typical for comets in our solar system. For all its modest size and vast distance, 3I/ATLAS was already challenging assumptions about the nature of cosmic wanderers. Before the world could catch its breath, the object's observed trajectory shifted again. NASA's Planetary Defense Alert System flagged this sudden change, not because of any risk to Earth, but as an anomalous event in itself. No gravitational explanation fit. Here was a chunk of ice and rock that seemed, in some sense, unpredictable. A key question emerged. Was this comet displaying only unfamiliar natural physics, or did it represent something yet unknown in cosmic behavior? The Atlas trajectory, a distinct path. Celestial mechanics, when working as usual, permit astronomers to predict the paths of interstellar objects with precision. An elegant hyperbola through the solar system, a close pass by the Sun, and an inevitable departure into space. Yet from its approach, 3I/ATLAS did not conform entirely. Arriving from the direction of Sagittarius, 3I/ATLAS entered the outer solar system on a rapid, determined path. Early projections indicated it would pass within 1.35 astronomical units of the Sun. That's inside the orbit of Mars, but well outside any danger to Earth or other major bodies. Still, the orbital calculations uncovered more than just a typical flyby. Further refinement of the trajectory revealed a remarkable alignment. At its closest approach, the comet would be on the far side of the Sun from Earth's perspective, making it extremely difficult, essentially impossible, for ground-based and even space telescopes to observe perihelion directly. While it is not unusual for comets to pass out of view during solar conjunction, the timing and geometry of this event were uncommon enough to draw scientific attention. Importantly, the sequence of its approach, perihelion, and exit were all confirmed to keep 3 I/ATLAS at a substantial distance from Earth, and at no time did calculations show any risk of impact. This apparent hidden perihelion increased the challenge for astronomers determined to study this rare object. Whether by cosmic coincidence or natural orbital mechanics, the result would be the same. 3 I/ATLAS would maneuver directly through the solar system's blind spot, leaving questions, at least temporarily, unanswered. The scientific community doubled down. If there were lessons to be learned from this rare interstellar visitor, they would have to be extracted before the comet vanished behind the Sun. Natural forces in the spotlight. Given the persistent anomalies in its trajectory, astronomers examined possible causes. A primary explanation in cometary dynamics is outgassing. When sunlight warms a comet's surface ices, jets of vaporized gas and dust are released, slightly altering course and speed. This rocket effect is well documented for long-period and near-Sun comets. Could 3 I/ATLAS simply be venting with unusual vigor, its composition producing outgassing more forceful than most? Spectroscopic studies suggested the presence of unfamiliar ices, possibly varieties not seen in the local solar system. The tail, bright and fast, was consistent with some of the strongest jetting observed. Data showed particles being hurled away at speeds several times higher than those measured for energetic comets like Encke or Hale-Bopp. Complicating matters was the detection of compounds in the tail and coma not commonly found in solar system comets. This raised the possibility that the comet's chemistry, presumably shaped in a different stellar nursery, was producing stronger or more volatile outgassing, generating the surprising accelerations. Still, the scale of the observed trajectory deviations taxed these natural explanations. Outgassing powerful enough to cause repeated course changes would be more typical of a much larger, more active object, and could risk the comet breaking apart, not remaining intact. Alternative explanations, such as gravitational nudges from nearby planets or asteroids, were ruled out by precise orbital surveys. The solar system is well mapped at this scale, and no local masses adequate for such deflections were found. No obscure planet or massive object lay in wait along the path. Electromagnetic forces, while present in the solar wind, are rarely sufficient to redirect a cometary nucleus. These continued oddities fueled active research and careful debate, but the prevailing position among planetary scientists remained anchored in natural processes, albeit at the extremes of what has so far been recorded. A record-breaking tale. As 3 I/ATLAS neared the Sun, solar heat triggered an extraordinary display. Like all comets, this interstellar traveler developed a glowing coma and trailing tail, but the rate and scale set new records. Instead of growing gradually, the tail shot out rapidly, forming over mere days and expanding far faster than usual. Multiple ribbons and filaments emerged, with colors indicating a complex mix of ionized gases and dust, suggesting chemical signatures not previously catalogued. Spectroscopic analysis revealed additional peaks and dips in brightness, mysterious, but still under investigation. The formation of the tail closely matched the infographic deviations in trajectory, suggesting, if not confirming, a causal connection between the comet's outgassing and course changes. Some theories proposed a feedback loop. High-velocity venting not only set the tail aglow, but spun and nudged the comet, creating unexpectedly large orientation changes. As each new jet appeared, recalculated paths showed additional small but cumulative effects, a plausible, if remarkable, demonstration of nature's to work at the boundary of physics. The broader scientific community, while challenged, focused on gathering as much data as possible before the opportunity closed. 3I/ATLAS had established itself as an outlier, still governed by natural law, but one that pushed those laws to their limits. What lies within? NASA's size estimates. Throughout, NASA and other agencies devoted considerable effort to estimating the physical composition and size of the comet. High-powered radar imagery, along with measurements from ground and orbital telescopes, converged on a solution. The nucleus, or core, was larger than initially guessed, roughly half a kilometer across. Despite this modest size, the comet emitted prodigious energy and gas, producing the vast, brilliant tail. This mismatch between small core and large output intensified interest. Tracking the object's precise position was challenging. Each recalculated fix revealed small but persistent discrepancies, consistent with ongoing jets and surface shifts. Across the network of professionals and amateurs, worldwide collaboration accelerated. Open data, rapid analysis, and global crowd science marked the project. University groups released findings in near real time, and citizen astronomers provided crucial detection reports as the object slipped lower in the evening sky. The companion object, not yet confirmed. Near the margins of instrument sensitivity, a second object was tentatively detected moving in the vicinity of 3I/ATLAS. Preliminary data suggested it might be a fragment or perhaps another piece traveling a similar path, but there is no strong consensus on its nature. Further detailed spectroscopic comparison would be required to confirm if this object is indeed physically associated or simply appeared along a nearby trajectory. To date, it remains a topic of observation and analysis rather than established fact. Evidence in context. No threat of impact. With anomalies in tow and rumors swirling, a key concern stayed present. Did this unusual behavior present any danger to Earth or other planets? Thorough calculations consistently showed that 3I/ATLAS would remain more than 1 AU from Earth at its closest, about 150 million kilometers. No scenario placed it on a collision course with Earth, any planet, or even major asteroids. This reassurance allowed astronomers and the public alike to focus on the scientific puzzles rather than potential danger. Still, the unpredictability of 3I/ATLAS's trajectory inspired reflection. If observations could be so unsettled by a single interstellar object, what of other undetected passers-by? The apparent limits of our detection methods were made uncomfortably clear, reminding us that there is far more to learn about the boundaries of our solar neighborhood. A pause at the Sun, observational limits. By late September, telescopes worldwide were reaching their observational limit. As 3I/ATLAS neared the Sun, it dropped lower in the sky, lost in twilight glare. Data suggested that by late September, and certainly into October, the object would be too close to the Sun to observe with existing Earth-based or even orbital instruments. The comet and its possible companion would be invisible, traversing a blind spot behind the Sun, shielded from direct scrutiny. Indirect observation through changes in solar wind, interplanetary dust, or gravitational effects would be the only way to infer ongoing activity behind the Sun. Scientists were developing predictive models to anticipate any detectable signals or consequences of perihelion, though direct imaging would pause until the object eventually re-emerged. Natural anomaly or something more? Through all these developments, speculation drifted between passionate skepticism and measured excitement. The comet's record-setting outgassing, surprising trajectory changes, and unfamiliar chemistry provided fodder for debate. The precedent of previous interstellar objects, such as Oumuamua and Comet Borisov, highlighted just how diverse these visitors could be and how difficult it is to assign them to simple categories. One Harvard astrophysicist, noted for earlier bold hypotheses about interstellar probes, suggested that if no natural explanation sufficed, the possibility of a technological or artificial origin could not be completely ruled out. While such views often provoke controversy and caution, the point remains: science advances by considering the full range of possible explanations, even as it demands rigorous proof. To date, all data for 3I/ATLAS support natural origins, albeit from a context, a distant planetary system not yet explored directly. No unambiguous evidence points to technological artifacts or deliberate control. Still, the boundary between natural anomaly and unexplained phenomena is thin enough to warrant continued investigation, always mindful of scientific rigor over speculation. The stage of perihelion, passing behind the Sun. As 3I/ATLAS and its possible companion approached perihelion, closest approach to the Sun, telescopes worldwide marked their final observations. The calculated rendezvous occurred on the Sun's far side from Earth, beyond direct view. Space agencies published their final predictions, and the Professional Amateur Data Network logged its last detections for months. At this juncture, NASA and its partners acknowledged a pause in direct monitoring. The brightness of the Sun prevents observation of distant small objects passing behind it. Only indirect signals, gravitational, electromagnetic, or through possible post-perihelion outgassing, offered hope for clues about events on the solar far side. Whether the possible companion would remain bound, break away, or reveal further surprises remained unknowable for the immediate future. Humanity's view thus shifted, awaiting re-emergence months later as 3I/ATLAS appeared, if at all, from behind the Sun and once more became visible to telescopes. Looking ahead, the enduring mystery. What remains after this episode is more than just awe. It's renewed curiosity and humility. 3I/ATLAS exemplifies how a single discovery can stretch our understanding of planetary dynamics, interstellar chemistry, and observational strategies. Though it ultimately posed no risk of impact and did not reveal unambiguous signs of technological origin, it highlighted how much remains to be learned from these rare messengers between the stars. Perhaps in time, future observations will explain its most dramatic maneuvers through the interplay of exotic ices, varying sunlight, and the physics of outgassing. Extreme, but not impossible, for a body born around another star. Or perhaps there will remain, for years to come, questions about the outer limits of what the cosmos can surprise us with. The legacy of 3I/ATLAS is assured. It has united scientists and amateur observers, driven technological innovation in real-time data sharing, and emphasized the need for ever more sensitive observation techniques. It forces us to look closer and to accept that even our best models have boundaries. For the foreseeable future, astronomers will watch for reappearance, hoping for post-perihelion sightings and the chance to refine models for interstellar comets. Each step, each measurement, can teach us not only about this particular object, but about the invisible traffic of our solar system and the vast, ancient processes that send such travelers our way. As we wait for new data or for the arrival of the next cosmic wanderer, we are reminded the universe is a place of infinite subtlety and complexity, with far more questions than answers. The ability to persevere when confronted with the unknown is the hallmark of science and of humanity's enduring quest to understand our place in the cosmos. Stay curious, there are mysteries yet unfolding, just at the far edge of our sight, and the cosmos, as ever, is not finished surprising us.